Hey everyone, Mr. Spooner here to teach you about three applications of rates, ratios, and proportions: density, scale, and similarity. Get your calculators ready. We're traveling to the real world for these problems. And away we go. All right, first thing is density. If you've ever picked up something in your life, this is heavier than I expected, it's probably because it was very dense. So density is just a ratio here. It's a rate between mass and volume. When we say mass, you're talking about the weight of an object. Volume is how much space an object takes up. So you'll see in the next couple screens, I'm going to ask you to calculate density. You're going to have to figure out the mass and divide that by the volume. That's going to be your answer. Now, occasionally, I might give you the density and volume and ask you to find the mass. In that case, you're going to multiply density times volume. If you want to figure out how I got that, think of this top one. And if you put this over 1 and cross multiplied, you'd get this right here. Same thing for volume. I ask this less frequently, but if you want to find volume, you would do mass divided by density. Let's do some problems. All right, first one. We've got some granite, apparently with some eyeballs and an eyebrow here. So we said before that density is mass over volume. You will need to remember that. And let's think here. The mass is how much it weighs. That's 14.5 ounces. The volume is how much space it takes up, in this case, 9 cubic inches. Break out your trusty calculator, divide 14.5 by 9, and you will get 1.61. We'll stop there. It goes 1, 1, 1, 1, 1, 1. And now the tricky part here is you need the correct units. You're actually going to use both parts here. So it's 1.61 ounces per a cubic inch. And I don't like my little thing right there. You need your units each time. That means for every cubic inch of that granite, you would expect it to weigh around 1.61 ounces. All right, why don't you try this one on your own? I've got some different trees here. Pause the video, try to figure out the density of each one, and then tell me which one is the more dense of the two. All right, I'm back. The oak was 740 kilograms per cubic meter. The pine was 450. So which one's more dense? Well, the one that's bigger, the one that's going to weigh more for each cubic meter, the oak tree. That's density. Let's do some scale. Scale, I always think, is a great thing because if you wanted to make a map of the world and scale didn't exist, it would actually be as big as the entire world. So scale allows us to see really big distances, but in smaller, still proportional areas. So let's look at this. The scale of this photo is 1 inch for every 130 feet of the Washington Monument. So every inch, do my little inch thing here, look at my inches, is going to represent 130 feet. So all you do here is if you know that this is 4 inches high, how tall would the real Washington Monument be? Well, this one you can probably do in your head, but humor me as I set it up. You would say 1 over 130. So here is the scale factor. 1 inch represents 130 feet. Well, on my computer screen, I have 4 inches. So how tall would the actual Washington Monument be? Well, I can cross multiply. 1 times x is just x. 4 times 130 is 520. Always check to make sure your answer makes sense. 520 feet? That seems reasonable to me. So this is one where I gave you the scale and had you figure out the real world measurement. I can also tell you the real world measurement and how the size on my screen or on my map or whatever and ask you to find the scale. In this case, all you're going to do is divide. So here I've got 2.2 to 305. And now I might actually go the other way just so it's a little easier for your calculator. So I'm going to make it 305 to 2.2. On your calculator, you're going to do 305 divided by 2.2. And I'm going to round here, but I got 138.64, we'll call it, to 1. So that means that the scale here would be, you normally see the smaller number first, 1 to around 138.64, and you could round that if you wanted. So now you could use that scale to figure out, in this case, the photo, but if you had something else that was the same proportion, you could use that information. So when I ask you to find the scale, I just want you to find the two numbers and figure out the ratio as a unit rate, where you get that bottom number as 1. All right, last thing, similarity. Similarity is a technical math term meaning these two things. Number one, that corresponding angles are equal, and I'll show you what that means in a second. And number two, that corresponding sides are proportional. This is basically when you see shapes and they have the same shape but a different size. Also, if you ever see this little squiggle, that is the universal math symbol for similar. So in this case, let's do the first thing first about the corresponding angles. I see that I have 40 degrees for this top angle of this hexagon. Well, down here, this angle is 50 degrees. You know what y is going to be? Even though it's a bigger shape, that angle is still equal. So it turns out that y is going to be 50 degrees. Okay, corresponding sides are proportional. That's going to help us find x. All again here, I just set up a proportion. I see that the side with 5 and then this side of the bigger hexagon is 7. That's our scale factor. Those two are corresponding. They're both on the left side. So I'm going to set up a little proportion here and say 5 is to 7 as 4 is to x because those two sides are proportional as well. They correspond. I do a little cross multiplying. I say 5x equals 28. Divide by 5, divide by 5, and you can leave it as an improper fraction. X is going to be 28 over 5, and in case you wanted to figure that out, it's going to end up being 5.6, I think. But you're welcome to leave it as 28 fifths. So angles are the same if they correspond. Sides are proportional. Let's try one more of these. Um, Pause it here. We're going to say that these two check marks are similar, which means the corresponding sides are proportional. Pause it, see if you can figure it out. And we're back. Did you get that x was 21? Because our scale factor here was 3 corresponded to 7. And then y that's 72 over 7, which is like 10.4, 10.5. But again, you could leave it as 72 over 7. So that was density, scale, and similarity. Hope this was helpful. See you later.